This conference will now be recorded.
Hello, everybody. Jordan Girth here from the National Weather Service Office of Observations. Thank you so much for joining us for the Satellite Book Club Seminar Series. This is session number 142. Hope your spring is going well. Today's presentation, an unusual midwinter HSLC event across northern Ohio on January 19th, 2023. We're glad to have Douglas Kahn, meteorologist from the Forecast Office in Cleveland, Ohio, with us. And our discussion after the presentation will be facilitated by Brian Curran, Science and Operations Officer at the Weather Forecast Office in Midland, Texas. Before we get started, I wanted to highlight a satellite accomplishment in Europe. The first image from EUMETSAT's newest satellite, Meteosat third generation I-1, Imager 1, reveals conditions over Europe, Africa, and the Atlantic with an extraordinary level of detail, very similar to our GOES-R satellites. The first light image was captured by the satellite's flexible combined imager at 1150 UTC on 18 March 2023. This is an important step for Europe and will provide improved imagery to the National Hurricane Center and Ocean Prediction Center that use imagery of the Eastern Atlantic to monitor storms. So check out that imagery of MTG-I1, the FCI, and soon hope to have that in front of our forecasters that need that imagery for monitoring storms that may be headed toward the U.S. this hurricane season. All right, let's dive in back to today. Just a few reminders before we get started that this session is being recorded. There will be an opportunity for Q&A after the presentation. If you are from a forecast office or regional headquarters, we're particularly encouraging you to ask a question. And please note your question in the chat, and we'll field them that way. If you want to ask your question out loud, that's great. Just note so in the chat, and then you can unmute and ask your question or add to the discussion at the appropriate time. If you're signed in with an office account, please note your full name when you ask your question so that we can address you accordingly. Also, if you're looking for tower rescue communications that you may not have been receiving, check your spam folder. Unfortunately, Google is gobbling up some of our important messages. We're always looking for future presenters. If you're interested in being part of our Satellite Book Club, contact the TowerS team. And if you're looking for training materials, Brian Mata, the Office of the Chief Learning Officer, can help with that. I have a lot of people to thank for our Satellite Book Club, including our TowerS team, Kashad Bowman, Emily Maddox, the Office of the Chief Learning Officer, the GOES-R, JPSS programs, and our presenter facilitator, and all of you for being with us today. So let's dive right in. Doug Kahn has been a meteorologist with the National Weather Service at the Weather Forecast Office in Cleveland since January 2019. Doug is originally from the Baltimore, D.C., Virginia DMV area, which is where he spent the first 21 years of his life and received a bachelor's from the University of Maryland, College Park. Doug then moved to Alabama for 18 months to work on his master's degree utilizing data from the GLM at University of Alabama in Huntsville, and then completed his master's thesis shortly after accepting a position at the Cleveland office, where he is the satellite and fire weather focal point. So we're glad to have him today. I'm sure this is going to be a great presentation. Doug, welcome back to the book club.
All right, thanks, Jordan. Just making sure you can hear me loud and clear.
Absolutely, 5 by 5.
All right. Well, good morning, everyone. So today I'll be talking about another high shear low CAPE case. Some of you may remember last year I gave a presentation on a high shear low CAPE case that we had in October of 2021. This one will be a little bit different. No tornadoes in this case, and it was actually much better forecast than the October event of 2021. So let's dive right in here. All right, so here's a general outline of what I'm going to be presenting today. So I'll be giving an overview of the event, followed by the forecast progression. Then go into some mesoscale analysis using the SBC, meso-analysis as well as some of the sounding comparisons. There was a special 19Z sounding from the day. Then I'll be going into some satellite and radar imagery, including that from NUCAPS and the GOES derived products. And then finally, something exciting that's coming down the pipeline. I'm going to be giving an introduction to WES-in-the-cloud, which will, I think, really expand our abilities as trainers and forecasters trying to look back at past archived events. Because we can always learn more in the weather enterprise. All right, so some quick facts from the event. So we had a high shear low CAPE environment that developed across the Ohio Valley and Lower Great Lakes region on January 19th, 2023. Like I said in the first slide, the environment was more favorable for damaging wind gusts, less so for the tornado potential. Something interesting about this event as well, something that you get a lot of in the cool season, is that there were a combination of thunderstorm and non-thunderstorm wind gusts, likely owing to the very strong antecedent wind field that happened to occur coincident with the thunderstorms that impacted our area. And there were even a few instances of hail that were found upstream across portions of central Indiana before transitioning into more of a damaging wind threat as the thunderstorms moved into northwest Ohio. Now, in comparison to the October 2021 event, this event was actually moderately well forecast with an SBC slight risk on even the day 2, followed by an upgrade on the day 1 13Z outlook to an enhanced risk, mainly for damaging winds. Now, across the southern half of the enhanced risk area, this is where a majority of the reports were that of the non-thunderstorm wind gusts versus thunderstorm wind gusts. I also mentioned that there was a special 19Z sounding. The Wilmington, Ohio office did launch a 19Z sounding, and we'll be comparing this sounding to some of the NUCAPS soundings from the day. And that brings me into my last point, in that clear skies are not something that we usually have around here in the Great Lakes region in the winter. So I thought this was a pretty special case in allowing us to utilize the NUCAPS satellite for favorable retrievals. All right, so like I mentioned about the forecast, day 3 we just were in a general thunder, but even as early as the day 2 6Z outlook, we were in a marginal risk. Then followed in the top right corner, upgraded to a slight risk, and then the morning of upgraded to an enhanced risk across the area. So next I'll be delving into some of the SBC meso-analysis images from the day. All of the following loops will be from 15 to 0Z. So we'll start with this image here, showing the surface temperature, dew point, and pressure bars from across the area. So the red and gold outlines here are the temperature, and then your dashed blue lines are the dew points. So note that the dew points, they really only maximize in the upper 40s across northwest northern Ohio. Actually had a little bit of a minimum since we mixed out so well in central and southern Ohio. The dew points actually fell into the upper 30s in some spots. Next, we'll be looking at the 2-hour pressure rises or pressure changes across the area. Note that there were, fairly meager pressure falls ahead of the front, but behind the front, there were pretty substantial pressure rises in excess of 4 or 6 millibars in 2 hours. And this likely, we can attribute this to some of those non-thunderstorm wind gusts that followed the cold front. Next, I'll be looking at the 3-hour dew point changes. So note that I mentioned that we really mixed out in central and southern Ohio in that southern half of the enhanced risk area. Well, this is where we had some of our largest dew point changes in a 3-hour period. As low as, or as high as 8 to 12 dew point changes in a 3-hour period. Whereas if you look at closer to the lake in northwest northern Ohio, the changes were relatively almost neutral. So we're kind of maintaining that moisture, that low level moisture, with dew points in the mid to upper 40s. And next we'll be going into the low level lapse rate. So like I mentioned, this was primarily a damaging wind threat day. So we really want to see those low level lapse rates enhanced, greater than 6, 7. In this case, even reaching in excess of 8 at some point. And even extending all the way north into the Cleveland area, northwest Ohio. So the low-level lapse rates were definitely favorable in this case. Next, we'll be looking at the surface-based CAPE and convective inhibition. Note that the surface instability, at least in our area, only maximized around 500 joules per kilogram, but this is more than sufficient for a cool season, high shear, low CAPE environment, especially given the strong shear. And then here are the LCL heights. So you'll notice LCL heights were generally greater than 1,000 meters throughout the entire day. So just another aspect of the environment that was really limiting the tornado potential for the day. Especially across that southern half of the enhanced risk area, where your LCL heights, I mean, you mixed out so much that your LCL heights are pushing greater than 2,000 meters now. And then finally, I wanted to show one of the parameters that proved useful in our 2021 October tornado outbreak. So this is the modified SHRB parameter, and the bottom right is the equation. One thing I wanted to note is that the low-level lapse rates are included in this equation. And one of my hypotheses is that the extreme low-level lapse rates that we experienced in this case were really amping up some of those values. Although we did have a fairly strongly sheared environment as well. So you'll note the anything that's higher than a red or higher than 3 will be in that sort of magenta purple color. Anything greater than 1 is favorable for severe weather, whereas anything greater than 3 is extremely favorable for severe weather, and that's including tornadoes, damaging wind. So it's not specific to just tornado genesis. And you'll notice near the end of the loop, 22, 23Z, which I'll show you here in the next image. This was the MOSH parameter at 21Z. And note that gradient, you want to really look for the gradient, just like in instability parameters. You want to look for the gradients and then even some of those tongues of instability. So in this case, we have a little bit of a tongue of the MOSH extending north and northeast along the lakeshore into the Cleveland area. And where this box is drawn out here is where we actually did receive a majority of the thunderstorm wind damage reports. So next I'll go into some of the satellite products that aided in the near-time mesoanalysis for the day. So here's a little bit of a background on the NUCAPS satellite algorithm. So it's an algorithm that's used to process the temperature and moisture information from 2 different sounders, the CRIS and the ATMS for the these 2 polar orbiting satellites, the SUNY NPP and the NOAA 20. Now, one thing I want to note is that the SUNY NPP will be replaced probably later this year, since the new NOAA 21 satellite was launched later last year. So that transition will be taking place sometime this year. Now, some pros for the NUCAPS is that it does represent the real atmosphere. So in comparison to even like the GOES derived products, which is implementing some of that RAP background data, this is actually the real atmosphere if you can get a clear sky or even very thin cloud cover. Another thing that I like, especially with the NUCAPS, is that you can edit the N-sharp sounding that you get in AWIPS. So you can edit the surface layer based on your surface observations. And this can give you a more representative environment. And then it's also good for pre-convective environments, whether that be convective or even winter weather. If you're looking for even, let's say, lake effect snow and snow squall environments, since that's also has a convective nature to it. Now, some of the cons, like I mentioned, it's good in clear skies and in thin cloud cover, but not in cloudy or thick cloud areas. The temporal data is lacking, although for our area, it actually does seem to work because the satellite passes usually occur between 6 and 7 Z across the eastern CONUS in the morning and 18 to 19 Z in the afternoon. And this is between, I mean, we don't launch balloons at the Cleveland area, but this helps fill a data gap. Otherwise, that would be filled by the 0 and 12 Z balloon launches. And then finally, there is some boundary layer smoothing. So, don't expect to see some of those microscale perturbations you may see in observed soundings. So thanks to Scott Lindstrom for this, these two images here from the NUCAPS. So what you're looking at on the left is the data availability with the visible satellite from GOES overlaid. So where you're looking at the green is where you have the good retrievals, clear skies, thin cloud cover. Once you're starting to get to the yellows, the data quality could be a little obscured. And then once you're getting to the reds, you shouldn't be using any of that data, especially in the really thick overcast areas. But in this case, we did have a very clear slot. We had a big dry slot, clear area, allowed for great retrievals from NUCAPS. So on the right is a toggled image between what I'm going to call is sort of the low to mid-level lapse rates, the 850 to 700 millibar layer, and then the total. So this image right here, what you're seeing is right now is the total totals, and then toggled with the mid to low level lapse rates here. So another thing we can do, other than look at the plan view of NUCAPS, is we can look at the actual individual points, the point soundings. So this is a point from Sandusky, which is just west of the Cleveland area, right along Lake Erie, across northern Ohio. So the data readout in the top box is, no adjusted data whatsoever. This is just the raw NUCAPS. When you adjust for surface observations, one thing in particular, you want to look at the surface CAPE. It was 0, and now once we ingest some of those surface observations, temperature dew point data, and now we have surface-based CAPE in excess of 250 joules per kilogram, even in excess of 400. In addition, the surface lapse rates, or low-level lapse rates, also increased from 7 to 8 Celsius per kilometer. Now, in comparison to one of the NUCAPS soundings in the Wilmington area, again, we have the top readout box showing the non-adjusted, the raw NUCAPS data readout. Now, when we do adjust for the current surface and temperature and dew point, we only get a surface-based CAPE of only about 100 now. So note that even with the adjusted surface temperature and dew points, because the dew points were much lower down in central and southern Ohio into the 30s versus the 40s that we had in northern Ohio, this contributed to much less instability at the surface, much more dry air. And then finally, with NUCAPS, we can also look at sort of like a sounding readout. And you can do that in AWIPS. You can mouse over all of the green points, and it'll show you these little postage stamp soundings. But you can also open it up in like in AWIPS in a larger view. So on the left is the Sandusky sounding. On the right is the Wilmington sounding. Both of these are adjusted using the surface observations. So note the general shape The mid-level lapse rates are very similar. We got dry air in the mid-levels, but at the low levels, something that NUCAPS is, may not see all the way to the ground, those surface observations do start to come into play. So notice that on the left in Sandusky, we have a lot more low-level moisture versus the Wilmington sounding on the right, which has a lot more dry air at the surface than Sandusky. So I mentioned earlier that there was a special 19V sounding from the day. So the left-hand side here is the WP surface analysis from 18Z. And the star depicts where the Wilmington sounding took place. So on the right-hand side is the Wilmington sounding, the observed sounding. So note that you're seeing a lot more of those microscale perturbations that you may not see on the Wilmington sounding from NUCAPS here on the right-hand side image. But the general shape does look very similar. You do have that dry air near the surface as well as in the mid-levels. I mean, your mid-level lapse rates are almost similar, 6.4, and from Wilmington, the NUCAPS had a 6. So pretty good confirmation there in the mid-levels of the atmosphere. So now I'll go into some other satellite imagery from the day, which I use the infrared satellite a lot and adjust the color curve for different times of the year, depending on what type of situations I'm looking at. So in this case, all of these, so the infrared satellite in this image is actually adjusted. The color bar is adjusted downwards to sort of account for these cooler season events. And that's overlaid the GO-16 on the left-hand side here, the lifted index, which is derived from the GO-16, in addition to the RAP background data. On the right-hand side is the same infrared satellite image overlaid on the GO-16 derived CAPE product. Now, for both of these products, I take it with a grain of salt. I don't take the exact values, but for especially like the surface-based CAPE on the right-hand side, I like seeing the change. So you're seeing that area pop up ahead of cooling cloud tops. You have your best low-level moisture, especially in the enhanced risk areas in northern Ohio. So, that should start to maybe ring some alarm bells, and maybe these storms will continue to strengthen, intensify, versus what you may see in the bottom, in central and southern Ohio, where the cloud top cooling rates aren't nearly as impressive as across the northern half. So what happened during the event? So we had our wind damage reports across northwest and northern Ohio, but you'll notice in the rest of the image that other actually were non-thunderstorm wind gust reports. And some of this can likely be attributed to that strong wind field that I mentioned early in the presentation, in addition to those large pressure rises behind the cold front. And then another pretty cool aspect of the event is there were some upstream hail reports that I mentioned in Indiana, which then transitioned to a damaging wind threat as they crossed the border into Ohio. So here's the radar imagery from the event as the storms entered the Cleveland area. Excuse me. So in this loop, we have severe thunderstorm warnings, LSRs from the event. And you'll notice in the beginning of this loop, our strongest cells did occur in northwest Ohio, on the northern flank of this line. On the southern end of the line, there was a really lack of lightning, convective intensity, and I think that is what led to there being more of non-thunderstorm wind damage reports versus the thunderstorm wind damage report. So I'll sort of wrap up this presentation by discussing some of the new capabilities that are coming soon to forecast offices, or at least I hope soon. So this is the WES-in-the-cloud. I was able to actually use my own procedures and perspectives to sort of provide a warning forecaster perspective on the event. So what you're looking at here is a 9-panel from the Cleveland radar, sort of showing a lot of the base products as well as some of the dual pole products from the event. So I think this will really be helpful in the future. We're not going to have to be waiting on builds. Well, for the WES in particular, we'll have whatever products we'll have operational. We'll be able to look at WES-in-the-cloud. So here's another panel that I have in my left-hand side of my severe perspective. And it's showing our 6 nearest radar sites, with the top left being Cleveland, and then Detroit, Fort Wayne, Wilmington, Pittsburgh, and Buffalo. Now, this is perhaps more useful in the summer season or the warm season, where you're trying to look for those cores developing aloft. But it can also be useful for the radar orientation. Let's say you have your storms moving sort of parallel to the radar beam, and you want to quickly look at another radar, maybe trying to look for some of those marked signatures aloft. Well, this is one of the panels in which I can do that fairly quickly. And then finally, this is my right-hand display on my severe weather perspective. And this is sort of a situational awareness, but also I try to sort of mesh all of the MRMS and satellite information in all in one panel. So on the right-hand side, I actually have, since this was in January, and the storms actually arrived following sunset. So I had to switch over to my nighttime microphysics product, but I also overlaid the infrared satellite, and I also used a specific color curve for my infrared. And that's actually one of the things that I currently use today. And what I do is I cut off the infrared at -25°C, and that allows me to see more so in the daytime. I can overlay that with the red visible band or even the day cloud phase distinction product. So you can see that initiation fairly well. You can see the texture of the clouds. But once the storms become more mature, then I can also look at how are the cloud tops cooling? What are the temperatures of the cloud tops, and that sort of information. In the top left here, I have we're fortunate to have some terminal radars across the area. So this is our terminal radar from the Oberlin site. So noting some of those higher velocity values associated with the approaching thunderstorm line. One last thing that I'll sort of explain is with the GLM, the Geostationary Lightning Mapper. In the cool season, I will adjust down the color bar to sort of make some of the bigger updraft or the stronger updrafts stand out a little more. Now you can see this sort of with the GLM minimum flash area, and that's actually right above the flash extent density area. So where you see the smaller flashes, the idea behind that is that you're seeing some of the younger updrafts, perhaps stronger updrafts as well, versus some of your larger flashes may be more associated with more mature, decaying stratiform regions of the storm. So in summary, we had a high shear low CAPE environment across the Ohio Valley and Great Lakes region, and this resulted in numerous thunderstorm wind damage reports. The overall reports were perhaps not as widespread as the entire enhanced risk area, in part due to the extreme dry air in the mid-levels, which did get transported down to the surface. Once again, the MOSH parameter did prove useful in determining where severe storms may form and persist in the near term. Relatively clear skies allowed for good quality satellite retrievals from the NUCAPS, in addition to the derived GOES products. And in comparison to the 19Z sounding, this also did aid in the near-time or the real-time mesoanalysis. And finally, some exciting stuff in the WES-in-the-cloud did show utility for future replacement of the legacy WES systems at the National Weather Service WFOs. So I think with that, I'll end here and take any questions.
Hey, thank you, Doug, for a very good presentation on a high shear, low CAPE environment. I'd encourage everybody to stay on for the discussion, especially those at field forecast offices and regional headquarters. For those who are asking some questions, please specify your full name in the chat when asking the question. Also, too, Emily will be posting shortly a short survey in chat. If you can complete that feedback survey, that would be very helpful. Now, in a week from today, on Thursday, May 11th, at 12 p.m. Eastern Time or 17Z, Dr. Patrick Duran, research physical scientist from NASA Sport, will discuss the Tropics mission. Everyone, if you have some questions or issues or concerns, please feel free to reach out to the Tower S team, specifically Lee Byerly, Kashad Bowman, and Emily Maddox, for questions about the Satellite Book Club or for configuration of satellite products. And with that, I'll go ahead and get to questions. Andrew Orson had just a general question that someone may be able to answer. Why can't we have both NOAA 20 and NOAA 21 data available concurrently in AWIPS? Does anyone on the call know why we can't? Is it an SBN issue or?
Yeah, one of the biggest excuses in the Weather Service, we don't have the bandwidth for it. I'll tell you this though, we are looking at optimizing the bandwidth that we use for satellite data, and we're applying some additional compression to our GOES imagery that might free up some space. If we hear from our field offices that the additional set of NUCAPS would be beneficial to give you that slight change over time, give you some indications of whether there's stabilization or destabilization, I think we might be able to consider that. So, you know, Andrew, good point. If you could send me an email, nothing very long, just say, you know, hey, that would help us with that, or anybody on the call that says, you know, we really would benefit from that. We can kind of take those emails and staple them together and say, you know, here's the justification for why we want to do both. Thank you.
Thank you. Next question comes from Bill Line. Doug, do you ever leverage the GOES derived motion winds to diagnose vertical wind shear, surface ob to the DMW level?
Yeah, so you know, I've tried to look at some of the DMV or DMW data, but I haven't really delved that deep into using it in sort of like a real-time manner for severe weather operations. I've more kind of looked around and played in the plains a little bit, and I've definitely seen a few good blog posts on it for severe weather, but that's not something that I've really looked into in our area as of yet. But it definitely looks like something I can consider in the future.
Yeah, I was sitting here thinking, looking at the hodograph from the 19Z sounding and the steep lapse rates from 0 to 4 kilometers, that there'd be optimal momentum transfer downward that might explain some of the non-thunderstorm reports. Timothy Schmidt has a question. Ideally, how often would you like to have temperature and moisture retrieval profiles from space? Every 30 minutes, 1 hour, 2 hours, or 3 hours?
Well, I think nobody's going to complain if we get that data every 30 minutes, but I'm not sure how feasible it is, especially with these being polar orbiters. You know, for us, the 2 times a day does work because it supplements the data gaps from the soundings, and that would give us pretty much, you know, atmospheric data every 6 hours. I would just say as much as, you know, we can handle in our AWIP system.
Yeah, okay. Bandwidth, as Jordan said, is always going to be an issue there. Bill, I'm going to butcher your last name. I apologize. Bill Schboberg, do you think you gave some good rules of thumb for future severe weather events?
Yeah, you know, I
Specifically,
think,
more polar satellite soundings met up would be good prep for geo soundings.
yeah, you know, the specific values that you get, especially from like the GOES derived, I've found, at least for that suite of products, looking at the trends, you know, similar to even lightning data. You know, I've been trying to teach people here at the office that use the GLM, use some of those satellite products, that it's really more about the trends than the actual values, because really the actual values are going to depend on your background environment. So, I mean, going back to the question, I think that it can provide some rules of thumb, especially when looking at some of the parameters like the MOSH that I showed here. Let's see if I can find it. I saw a similar talk on the Lightning Cast product, talking about these gradients and cones, you know, areas of extended, more enhanced values. And so I tried to implement that in this talk, and it worked out pretty well, especially in real time when we were looking at some of this data in the SBC mesoanalysis. So I think looking at, you know, at least in the mesoanalysis aspect, looking at the gradients, looking at the cones, where can you expect storms to intensify and persist?
Cool. Becca Mazer has a comment for Jordan. You know, Alaska would be interested in more NUCAPS. I imagine they would. Steve Graffiti has a comment. He said, good presentation. And he has in chat a link to a 2006 weather and forecasting paper that they published on low dew point wind producing MCSs, much like the one that you presented. And the link is in chat for those wanting to pursue further. I think we have time for one more question. Does anyone have any questions they would like to ask Doug? I'll ask one real quick, if you don't mind. What other satellite products could you have used for this case if the NUCAPS retrievals were obscured by thick cloud cover, as is usually the case across the Great Lakes region in the winter?
Sure. So I would probably fall back on more traditional GOES data. So using the infrared satellite product with the user-defined scaled down color scale to sort of make those regions of stronger updrafts pop out a little more, at least in a situational awareness type display. But other than that, you probably wouldn't get much value of the GOES derived. And if it were cloudy at this time of year, you probably wouldn't get your surface-based instability, at least in this region. So we might be talking a completely different scenario here as well.
Cool. All right, Doug, I want to thank you for your presentation today. And with that, I'll pass it back over to Jordan for some final remarks.
All right, thank you.
All right, thank you. Outstanding presentation. Doug and Brian, great job facilitating that Q&A, and thanks to all of you that had questions and input for us. That's really why we do this. So Satellite Book Club is going to continue next week, 12 noon Eastern Time. Dr. Patrick Duran from NASA Sports is going to talk about the Tropics mission. So if you're interested in that, hope you'll join us. Exciting time for Tropics. And if you have any questions about the configuration of satellite products or the book club, as always, please get in touch with our TowerS team. You see the email addresses for Rashad Bowman and Emily Maddox there on the screen. So with that, we'll wrap it up today. Thanks again for all of you for being with us, and thanks again to our presenter and facilitator. Hope you enjoyed this presentation. See you next time. Bye-bye all.